Hey guys, welcome to today's lesson. Today's lesson is 6.5, which is subtracting mixed numbers using renaming. This is probably one of the toughest lessons to get. Once you get it, it makes perfect sense, but until it makes sense, it doesn't seem to make any sense at all if you can understand that logic. But I'm going to ask you to keep trying, don't give up, and we're going to take this lesson a little bit slower than we normally do to try and make sure that everybody is able to grasp this concept. So make sure you ask questions and get help when you need it. And let's go ahead and get moving. We're going to start by reviewing just really quickly a couple things that's going to help tie into today's lesson. So on the board here, we happen to have two different mixed numbers that could have been an answer during addition of two mixed numbers. It's very possible to get 3 8/3 as our answer. We talked about not wanting to leave it that way because we have a whole number and an improper fraction. So what we need to do is to change that improper fraction back into a mixed number. So we want to take 8/3 and switch it around. So we'd ask, how many times can 3 fit into 8 without going over? It can go in there 2 times. Once I take it away 2 times, I'm left with 2, and my denominator stays 3. So this fractional part, 8/3, is the same thing as having 2 2/3. So with that, we need to add this back to the 3. So when we add the 3 back in, we get 5 2/3. Down here, we have 7 12/8. We're going to forget about the 7 for right now because we want to convert that 12/8 back into a mixed number. 8 can go into 12 one time. Once we take it away once, our remainder would be 4, so that becomes our new numerator. And our denominator stays the same. It stays right there at 8. Now, I know I can simplify that. 4/8 is the same thing as having 1 1/2. And then I'm going to add it back to this 7. When I do, my final answer is 8 1/2. So hopefully by now we're comfortable enough with this that we understand how to do this. We're going to be kind of doing the opposite of this a little bit later in our lesson. Now here we have a simple subtraction problem. You probably learned this way back in 2nd grade maybe, I don't know for sure. But you learned something called renaming at this point in time. That we can't take 3 and subtract 7 from it. 7 is a bigger number, so we can't have 3 of something and give 7 of them away. So what you learned at that point in time was to borrow from here. So we reduce this 5 by 1, and then we bring the 10 over here. So now we have 13 minus 7, which now we can do. 13 minus 7 is 6. So we move on. Now we have 4 minus 6. Again, we can't do that. 6 is a bigger number, so we can't subtract it from 4. So what I have to do is borrow from over here. So this 2 becomes a 1, and I take that 1 that I borrowed and bring it next door and make 4 into 14. So 14 minus 6 is 8. Then I have 1 minus nothing, so I have 1. 186 is the answer. This was your very first experience with renaming. The only difference is now we're going to be renaming with mixed numbers. Instead of whole numbers, we can do it with fractional parts too. So let's go ahead and get started. I want you to write this down. This is what we're going to do. And this is really very familiar to what you already have done. Our first step with anything to do with adding and subtracting fractions has been to rewrite the fractions using common denominators. So it doesn't change here. We need common denominators before we can do anything else. Here is where things get a little different. If our first number, our first fraction, doesn't work well to subtract the second fraction, we need to rename it. And we just talked about renaming, but here it is again. What is renaming in mixed numbers? When you need to borrow a whole number to make the fractional part bigger. That's what we're talking about with renaming. So once we have renamed it, then we're back to familiar territory. We subtract the whole numbers, we subtract the fractional parts, and then we simplify if possible. So let's go ahead and try this. We have a fraction here. We have 5 minus 2 3/8. 5 is a bigger number than 2 3/8, so we can go ahead and subtract it. We have 5 whole boxes over on this side. We have 2 whole boxes and then 3 out of 8 here. Well, if we were to take and subtract the whole numbers, 5 minus 2, we would, we're going to take away, oh, I got to change my color. 5 take away 2, right? That's the same thing as these 2 over here. Let's change it to blue so you can see that on both. So 5 take away 2. Now I have these 3 blocks left, but I only need to take away part of one. So what I need to do is rename one of these blocks. I'm going to borrow 1 from my whole number, and I'm going to cut it up into pieces that match over on the red side. We have eighths already started, so no need to find a new denominator. Let's just cut it into eighths. So we're going to take this piece and we're going to cut it into 8. So now we have 1, 2, 3, 4 whole numbers, and 8 eighths is what we're going to rename it. This is exactly what we talked about in equivalent fractions, how at school I'm Mrs. Sorby, but I go home and I'm Mom or Christy. I'm the same person. This is still our same amount. We still have 5 entire boxes. The only difference is we're going to call it 4 and 8 eighths instead of 5. So we have 4 and 8 eighths minus 2 and 3 eighths. Now I have 8 minus 3. So I've got 8 pieces here. I can subtract 3, and I'm left with 5 eighths. When I take away these 3, I'm left with 1, 2, 3, 4, 5. And I have 4 minus 2. I have 2 taken here. So when you can see that we've taken this part here, this red part, and we've taken it away, that's what these parts represent. What we're left with is still 2 whole ones, and then 5 out of these 8 pieces here. So that's what we're talking about with renaming. Let's look again. If I have 3 1/4 and I take away 1 3/4, I check for common denominators. They're both fourths already. So I start looking at subtracting. I've got 1/4 minus 3/4. That's not going to work very well. So let's get a visual on this again. Pizza. Who doesn't love pizza? It's easy to slice. It's yummy to eat. So let's take a peek. I've got 3 1/4, which looks like this. I've got 1, 2, 3 whole pizzas, and then 1/4 of another pizza. I've got somebody coming over who's super hungry and wants to eat an entire pizza and then 3/4 of another one. How much is going to be left over for me and the rest of my friends? That's what I need to figure out. Well, like I said, the fractional part, this doesn't work to subtract this. So what I'm going to have to do is rename. I'm going to borrow from the 3. I'm going to drop that down into a 2. And then how many pieces am I going to want to slice this into in order to make it work with this? Well, I already have fourths started. So I'm going to, instead of leaving it as a whole number, now I'm going to have 4/4 plus my additional 4th for a grand total of 5/4. 2 5/4 is the exact same amount as 3 1/4. I just changed what I called it. So now I have 2 5/4 minus 1 3/4. This is going to work out for me quite well. 5/4 minus 3/4 gives me 2/4. 2 minus 1 is 1. This is my answer. I need to remember to look at it to see if I can simplify it first, which 2/4 I can reduce to 1 1/2 is the final answer when I take 3 1/4 minus 1 3/4. All right, let's try it again. This time we're going to try it without a picture. I've got 4 8/12 minus 1 11/12. I can do this. 4 is bigger than 1, so I can do it. However, I can't take 8 and subtract 11 from it. So what I need to do is rename. So we're going to reduce this one by 1. So now I've got 3 as my whole number. That 1 that I'm borrowing, I'm converting that whole number into 12/12. I already have 12 here, so that tells me what I want to reduce it to or convert it to. So I have 12 twelfths plus my original 8 twelfths. So altogether I have 20 twelfths. So now I have 3 and 20 twelfths, which again, these are equivalent. They're the same amount. If I was talking pizza or brownies, none of them would be missing. We would just have some cut and some not cut. I'm going to subtract 1 and 11 twelfths from it. And when I do that, 20 minus 11 gives me 9. So I have 9 twelfths. 3 minus 1 is 2. 2 and 9 twelfths is my answer here. I need to reduce it though. I hope you recognize that 9 and 12 can both be divided by 3. So when I do that, my 2 stays the same. 9 divided by 3 is 3. 12 divided by 3 is 4. 2 and 3/4 is my reduced and final answer. Good job, keep it up. So let's try this one. 7 and 1/6 minus 3 and 5/6. I can't take 1 minus 5, so I'm going to have to borrow. So this one gets reduced by 1. And then I have to take that 1 and convert it into 6/6. So I'm going to take this number on the bottom, whatever it is, that's my 6/6. Add it to the top, so I have a total of 7/6. And now I can subtract 3 and 5/6. 7/6 minus 5/6 is 2/6. 6 minus 3 is 3. 3 and 2/6. I can go ahead and divide both top and bottom by 2. So I get 3 and 1/3 as my final answer. How about here? I have 1/6 and 3/4. Remember, the first thing I need to do is find a common denominator. So instead of leaving it as 1/6, I need to convert these. What's my least common multiple for 6 and 4? I hope you realize that it's 12. So I'm going to take and change 1/6 into something over 12. And then I'm going to take 3/4 and change that into something over 12. And then I'll have my common denominator. 6 times 2 equals 12. So I have to take 1 times 2 to equal 2. 4 times 3 equals 12. So I have to take the top number times 3 to equal 9. So now I want you to rewrite it so we don't get things confused. I've got 9 and 2/12 minus 6 and 9/12. All right, I got the first step done. Now I want to take 2 and subtract 9, and I know that I can't, so I'm going to have to borrow. So I'm going to take this and reduce it by 1. I've got twelfths, so I know I'm going to be taking 12 twelfths from the one that I borrowed and add it to the 2 twelfths. So 12 twelfths plus 2 twelfths equals 14 twelfths. And I'm going to subtract 6 and 9 twelfths. So going through it, fractional part, 4 twelfths minus 14 twelfths, sorry, minus 9 twelfths leaves me with 5 twelfths. 8 minus 6 is 2. 5 and 12 don't have anything in common, so this is as low as it can go. So with that, I got one left for you to do. I want you to try it on your own, and we'll check it in class tomorrow. We do have different denominators right now, so don't forget your first step is to convert them to a common number, and then you're going to have to rename, and then you go through your normal process. So with that, good luck. Please come with all sorts of questions tomorrow so we can help to clear things up, and we're just going to keep practicing away until this feels natural. Have a good night. See you tomorrow.